Alrighty guys, let's go ahead and get started with our series and parallel notes. And these notes are going to talk about the two different types of circuits that we can see. So the first one we have up here is series, and we also have parallel. So let's dive into it. We're going to say that series means that the bulbs are going to share one circular path to the battery. I'm going to show you what that looks like right now. So over here in series, we can see that we have two light bulbs, and that's what makes this series here, is that we have our battery and then the wire connecting the light bulbs over, and then the two light bulbs side by side, and then back to the battery. So the reason why this is series is because if we were to unscrew one of those light bulbs, what would happen? Well, very plain and simple, since it's in series, if we break this circuit anywhere, that just means that the electricity is not going to flow through. And you guys probably don't remember, but back in the day when they used to make Christmas lights, they used to make them in series. So what does that mean? That meant that when one of those lights went out, the entire Christmas light strip stopped working. Obviously, this was a huge pain in the butt because if you wanted to fix your Christmas lights, you had to unscrew every light and replace it and see if that was the light that wasn't working, and there was really no way of knowing. So nowadays, they don't make Christmas lights in series anymore, thank goodness. They make them in parallel, and we'll talk about parallel in a sec. Here, I have the picture of the light bulbs and the schematic diagram next to it, and that's what it should look like if you draw it. This schematic diagram took the easy way of drawing the light bulb, which is just an X in a circle. Next, we want to talk about parallel. And parallel, we're going to say, is when each bulb has its own path to the battery. And the schematic diagram for parallel is going to look like this on the right-hand side. And here, again, we can see that we have our battery, we have our wires, and each of these light bulbs has their own path. Which really just means that if we were to cut the wire right here, the other light bulb would still work because it has its own path to the battery.
Now let's take a look at a parallel circuit. Well, we can see that for this parallel circuit, we have two different paths. We have this first path right here, where this current makes its way around, goes through this light bulb, and comes back. And then the second path, where the current makes its way around, goes all the way down here, through the light bulb, and then comes back. So let's see what happens if we disconnect the circuit here. Well, disconnecting it there shuts off this light bulb, but this one still works because the current still has a path to make it all the way around the circuit. Let's put this light bulb back, and now let's see what happens if we disconnect this light bulb here. Well, if we disconnect this one, the current can't make it through here anymore, so this light bulb shuts off, and this first light bulb is still working because it still has a path to the battery. Let's connect everything again, and now let's think for a sec, where could we disconnect this circuit so that neither of these light bulbs turns on anymore? Well, the easiest place is right at the battery, because that's where the circuit starts. So if I disconnect it here, I notice that it shuts off both of my light bulbs. And again, that's because there's no path that the electricity can take around it. The electricity, let's say if we started on this side, could go down here, over here, and back up here, but it never connects, so there's no flowing of electrons. Now let's go all the way down here, goes through the light bulb, back up, over here, and again, it doesn't connect, so it doesn't fully flow through, so there's no electricity.
But if we were to cut the wire right here on this one, neither of these light bulbs would work.
So if we were to cut this wire right here, let's see what happens. Well, if I cut that wire, my entire circuit turns off. And the reason is that this circuit only has one complete path from one side of the battery to the other. So if I break the wire anywhere, the electricity is not going to be able to flow around it. Now we see that electricity is able to flow through this circuit, so everything's all good. But it doesn't matter where. If we cut this circuit here, it's going to stop working. And again, that's because there's only one path for this energy to travel around the circuit.
Nowadays, this is how we make Christmas lights, because they realized that it was a pain in the butt and terrible idea to make Christmas lights in series. Now, if they're in parallel, if one of those lights doesn't work, no problem. We know exactly which light is broken. But back in the day, when one light didn't work, the entire string of Christmas lights was ruined and garbage. How do you think your house works? Do you think your house works so that if one light bulb in your ceiling goes out, that all the light bulbs are going to go out? Or do you think that your house works that if one light bulb goes out, that's fine, only one light bulb is out, and all the other light bulbs remain on? In other words, how do you think our houses are wired? Do you think that they're in series or parallel? Well, I don't know about you, but anytime a light bulb goes out at my house, that's the only light bulb that goes out. So that would mean that my house and my lights are wired in parallel, meaning that if one of those light bulbs doesn't work, it does not impact the other light bulbs. All the other light bulbs stay on, which shows me exactly where the problem is. So now that we have series and parallel in front of us, let's try to figure out which one of these is going to be brighter and which one is going to be dim.
All right, so if we take a look at this, I have my simple circuit here where I just have my light bulb, my battery, and my wire. And the question is, which one of these will be brighter, the one in series or the one in parallel? So let's go ahead, let's hook up the one in series. And we already notice that the one in series is dimmer than just the one light bulb connected to the one battery. And that's because this battery is sharing its energy to two of these light bulbs. So 100% of this battery's energy, 50% is going to this light bulb, and 50% is going to that light bulb.
If they're sharing the total energy from the battery, that's going to mean that these bulbs should be dim, and we can expect them to be dimmer than if they were in parallel.
Now let's see what happens if we have the parallel. Well, when I connect this, I notice that for parallel, these light bulbs are both really bright, and they're the same brightness as just one battery and one light bulb hooked up together.
So because it has its own path to the battery, it has its own supply of energy from the battery. Therefore, each bulb gets access to the battery's full voltage, making each as bright as the original. Think about this in terms of cereal. Let's say that you are eating cereal, and this is one bowl of cereal over here, and you and your friend have to split that one bowl. So since you guys are just splitting one bowl of cereal, that means that each of you is getting some of the cereal. But in this case, instead of this being the bowl of cereal, this is now the box of cereal.
And since each of you have your own path to the battery, it means that each of you gets your own bowl of cereal. Therefore, both of you are able to eat as much cereal as you want and feel content. All right, so let's answer these two questions really quick. Which battery do you think will burn out faster, series, parallel, and why? Well, since each of these light bulbs has their own path to the battery, they're each getting 100% of the battery's power. So basically, this light bulb is getting 100% and this light bulb is getting 100%, which really means that this battery is working twice as hard in order to power these two light bulbs, where this battery over here is just working normally in order to power these two light bulbs. So let's think really quick. If the battery on the right side for the parallel is working twice as hard as the battery in the series on the left side, which one do you think is going to last longer, the series battery or the parallel battery? Well, the series battery is going to last a lot longer than the parallel battery, and that's because the series battery is only using 100% of its battery, where the parallel is working twice as hard, meaning that it's using up that energy a lot quicker. Imagine the parallel battery is like you're on your phone and you are FaceTiming your friend and you're watching Netflix at the same time. Your phone is eating up a lot of that battery. The parallel circuit is going to use up more energy, meaning that our battery is going to go dead faster in the parallel circuit than in the series circuit. And the reason for that is that for the parallel, each of these light bulbs has their own path, which means each of these light bulbs can get 100% of the battery's energy. Where in series, they share the path, which means 100% of this energy is being divided amongst the two light bulbs, meaning one light bulb gets 50 and the other gets 50, assuming those light bulbs have the same resistance. So again, if we think about this in terms of cereal, and this is a box of cereal and this is the box of cereal, since these two light bulbs are able to each have their own bowls of cereal, where these light bulbs over here have to share a bowl of cereal, who is going to eat that box of cereal first? Do you think that it's the two people that are both eating out of the same bowl? Or do you think that it's these two people that each have their own bowl of cereal? Well, I don't know about you, but if that's some Cocoa Krispies, it's definitely going to be our parallel over here. And that's because they're taking the total amount that they can and they are using that amount. Where in series, they're splitting that total voltage. And again, in parallel, they each have access to that total voltage. So which battery will burn out faster? Well, that's going to be parallel. And like we said before, it's because all the bulbs have access to the full voltage of the battery, meaning that it will drain it faster. Draw two different schematic diagrams that include two batteries next to each other and three bulbs. So for parallel, should look like this, where we see that we have two batteries here. Again, the small part is the negative and the big part is the positive, and we stack positive to negative. And then we have some wire connecting around. Here's our first bulb here, here's our second, and here's our third. How do we know it's parallel? Well, we know it's parallel because if one of these batteries goes out, it doesn't affect the circuit at all. And again, how would we know if it affects the circuit? Well, if we start from the top, we have to be able to make our way all the way around. And we can do that on either path. I just did it on the outside. Now the inside goes here, goes over the light bulb, and then the middle over the light bulb. Now let's take a look at what it looks like in series. Well, series, again, here's our two batteries, and here's our path. We go up, here's our first light bulb, second light bulb, and third light bulb. How do I know it's series? Well, if one of these light bulbs is broken or there's a break in the circuit, I can't make it back around, which means that none of them will work. I go up, I go over. Let's say that this light bulb works, I go through it. This light bulb works, I go through it. This light bulb doesn't work, it stops here. I can't make it to the other side of the battery, which means that my circuit does not work. Main takeaways with series and parallel is that in series, if one thing doesn't work, the entire circuit stops working. In parallel, if one thing doesn't work, everything else can continue to work because there are different paths for those electrons to take. Another important concept about series and parallel is that in series, the more light bulbs you add, the dimmer the lights will get because the light bulbs are sharing that energy from the battery. In parallel, the more light bulbs you add will just keep the same brightness of those light bulbs. But if you think about it, in parallel, you're drawing the maximum power from that battery. So the more light bulbs you add, the more power you draw from the battery, and you keep adding more and more and more light bulbs and drawing more and more and more power. What do you think is going to happen? Well, think back to when you're in your bathroom and you're blow drying your hair and you're brushing your teeth and you're blasting the radio and you're charging your phone. What usually happens when all that stuff is going on? Boom, power outage, right? You pop a fuse. So that is going to happen in parallel. In series, you're not going to pop any fuses, but in parallel, you will pop a fuse. And we'll talk more about the reason for that, why in parallel we keep drawing more and more voltage later on in our notes after we talk about Ohm's law and solving for these mathematically.